Welcome to Ask and Learn.
Okay, let's go ahead and answer this question. So the question tells you y equals to 5e to the negative point 1, absolute value of x times sine of x minus 1. How many critical points do we have when this y is actually a derivative of a function f? Okay, so to find a critical point, what's important to remember is that first of all, it has to be a value of 0. And second of all, it has to actually be a sign change. So f prime has to be 0 and the points around it has to be from negative to positive or positive to negative. If you take a look at the graph, you can see that it's not one of those shapes where it's only touching the x-axis, so it's very likely that it's not going to be a point where f prime is equal to 0, yet it's not a critical point. So we're not going to have to worry about those things. Now, it's very important to see that there is a negative 1 right there. Because if it's not, you can clearly see that 0 is the average value of this function, and it'll very likely have infinitely many points as a critical point. However, the negative 1 shifts it downwards, so we have to be very careful with how many zeros this thing has, okay? Because, let's do something really interesting right now. 5e to the negative zero point 0.1, absolute value of x, shift it 1 down. As you can see, oh, let me try to change it. There you go. This is the number that is multiplied in front of the sign x, so it behaves like its amplitude. So how much up and down it goes depends on the value of this guy, okay? And it basically traces on top of the highest point where this graph can go. And as you can see, the further you go towards the right side, it gets closer and closer to 0. So it seems like at a certain x input, the height is not going to be tall enough that it can touch the x-axis, even though the graph wants to get close to it anymore. Okay, so that's one of the interesting things that you can see. Now, we're going to count how many points it actually crosses through y equals to 0. So we're going to start here. You got to be very, very careful here. If you go far enough, it looks like it actually touches the x-axis, but if you get closer, you can see that it actually is not. So this point, even though it's close, it actually doesn't count as a 0. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 it is. So you can see that all of these 10 points are x-intercepts, and it goes from positive to negative here, negative to positive there, so it's a sign change. So indeed, all of these zeros represents a critical point of f, because f prime is equal to 0 at those points. So to answer the question, how many critical points should f have? Well, it's going to be 10, and that's how I answer this question.